Welcome back. In the last video, we already looked at a method that can be used to generate meaningful word embeddings, meaning that words are represented by vectors, which are similar to each other if the meaning or like the contextual usage of a certain word is similar. Another method that was developed before that and is, I would say, even more popular is the Word2Vec model that has been developed by Mikolov et al. And so we're going to discuss this method in a few minutes. And again, we are sharing the idea of the model, and all its practical implementation and the issues that are related to it are going to be discussed in the Zoom session or in additional notes and lectures. And also what we like to discuss in this video is an extension of the idea of the Word2Vec model in order to not only generate meaningful word embeddings, so vector representations of individual words, but also at the same time generate document-specific vectors. So that means, for instance, if we take a look at certain news for companies, then each of the news will be represented by another vector. So that just means each of the news will be represented by a series of numbers. And again, the series of numbers, they will be similar if the content of the news are similar. Okay, and that is called the Doc2Vec model, so the document-to-vector model. Here, obviously, Word2Vec stands for Word2Vector model. For both cases, two versions of the model exist. When we take a look at the Word2Vec model, there is the implementation which is called the continuous bag of words, so the CBOW, and the skipgram model. And you will see in a minute that the Word2Vec model basically is a rather simple neural network, at least its architecture. Okay, so in comparison to the Glovi model, where we used the dot products of vectors in order to predict the occurrence of those words, the Word2Vec model is different in a way that it's not taking a global perspective. It rather draws a sample from the overall corpus. But given a certain sample, so that can be a sentence or a whole document, it tries to make predictions for a word given some other words. And when we use the implementation according to the CBOW model, that means we take the context, so the words around a certain word, in order to predict the probability for a middle word. That means I like text analysis. So for instance, if we see the words I like and analysis, there is a great likelihood that text is in the middle. And this is something that's supposed to be learned by the model and by its word vector representation. Okay, so we take usually like a word and then the context of this word and try to make a prediction with the context of this word in order to predict the target word. When we take a look at the skipgram implementation, it's like the other way around. That means we try to predict the context words with the target word in the middle. Okay. Again, exactly how we're going to do this and how we would do such a prediction, I am trying to explain this a little bit in a few minutes with a simplified example, or we can see it in the slides maybe. But this is like the two methods that both work fine in order to generate meaningful word representations, and it kind of depends on the size of the corpus and other things, which of the two versions perform sometimes better and sometimes worse. Okay, so how would we start doing this? So for instance, if we have financial data analytics, as I said, a very simplified example, then in the beginning we would have one-hot representations of those words, like as you can see them here. So financial is a vector that has a 1 in the first element and a 0 otherwise, and data is like it has its 1 on the second element, and analytics has the 1 on the third element. So here k is just the dimension of the word vector representation, and what we do here, we transform those, or we use this as input, you know, like the one-hot encoded vector. Then we use this to transform the one-hot encoded vector into the word vector, and then we deal it rather similar as for the Glovi model, meaning we're building dot products of the word vectors that we are interested in. So assume we would like to predict the probability that data is in the middle. If we observe the word analytics in the context, that means we simply calculate the dot product of those two word vectors and then transform them such that it's generating a probability. And then we take a look, or we calibrate the model as we would do it for a multi-class classification problem, meaning that parameters are calibrated in the way that probabilities are high if we observe like that, for instance, the word data is often in the context of, if the word analytics is often in the context of data. Okay, so what we have here, and I think it's best if we just go quickly to my own notes, or that I try this, write this down by hand, that you get an idea. So let me quickly try this. So what you can see here also in the slides, but I think it's going to be better if we do this step by step. So what we would have here is that, you know, if we have like our one hot encoded vector, for instance, which is let's do it like this. It's like the transpose form of the one hot encoded vector, and then we would have, for instance, for our three words, the corresponding word vectors. So U financial, U data, and analytics. So if you calculate this, so that is the one hot vector for financial. Then we have 1 times the first element times 0 times the second times 0 times this one. So what remains here, we have a, let's say if we have like 3 and let's say k is, I don't know, in reality would be 50 or 100, but here would be 2 or something. So we have a 1 times 3, and here we have a 3 times 2. Then what results would be a 1 times 2 vector here with like representing the vector of financial. Okay, let's make a 2 out of it. And here also, so k is equal to 2. And that's like the first step, okay? And now if this is like our context word and we're trying to make a prediction for the target word, then we take a look what for our sentence that you currently observe, we're observing that the target word is financial data. So meaning we would have another matrix, again, as you know it from the example from the Glowy video, with vectors that represent the target word here. So would look like this. And again, we would, you know, if the word is data, then our input from the one hot encoded vectors would be like this. Okay, so that's like the one hot data vector. So here we would end up with the vector of the target word data. And now what would be done would we would calculate the dot product, so of the financial vector in this transpose form times the vector of the target word data, and we use a transformation function in order to get a number here that is between 1 and 0, because that's supposed to be the probability for observing the target word data if we see the word financial in the context. And this is going to be the softmax function, because we are going to do this with all words. That means we end up with a vector with the probability of not only data, but also that we get the word financial if we observe the word financial, that we get the word data if we observe the word financial, and that we get the word analytics seeing the word financial. Okay, and but like this probability would be generated exactly as this one. Okay, just that we have different word vectors here. Okay, so I hope this helps at least a little bit, that you get a feeling what's been done, or what's done here mathematically. And basically it looks complicated, but what we're simply just doing is we take a look at the word pairs that we observe, or that we see in reality. In reality, we see that, for instance, we take a look at the word data in the sentence, then we take a look at the context words, and then we try to make the predictions. Okay, so given the context words, we take that vector and we calculate the dot product with the vector of the target word. And we do this then for all the words in the corpus, such that we have probabilities of observing the word data when we have financial, observing some other word when we have financial, observing another word when we have financial, and then we hand over the actual. So and this is like a multi-class classification problem. If the number of categories is equal to the amount of unique words that we have in our lexicon. Okay, so we can take a look at this example here. So like here is the analogy to the neural network. So the neural network would be, we have the input, then the input is typically at least has the dimension d, because d is the number of unique words here. So the second dimension is always the d dimension. Okay, and then we want to bring this down to a lower dimensional representation typically. So that is k. In order to, that something results with a dimension k, we need to multiply it with a matrix with the weights, that is d times k. And then we have our hidden neurons, and then as we are going to need an output whose dimension is equal to the number of unique words, because we have a multi-class classification problem with the number of categories that is equal to the amount of unique words in a lexicon, we also need to use this lower dimensional representation and bring it back to the d-dimensional representation. That is why we need those weighted matrices, and those weight matrices are the word vectors. So please do not get confused. I used u and v in my example, but this is what I meant with u, and this is what I mean with we. Okay, and here you can look how this would work. Okay, so if this is just if we really have only those 3 words in our corpus, then at first step, if we take a look at the example where we have data, then this operation here basically reduces this to a 2-dimensional vector, and which means just to 2 numbers. And then in order to make out of those 2 numbers a d-dimensional vector whose individual element is representing the probability for observing a certain word, then we need to first of all multiply this with a weight matrix. So here, that one times the first column will be the number that's going to be used for the probability of observing financial if we have data, and so on and so on. And that's such in a way that we have probabilities, we just need the softmax activation function. I mean, this is rather technical now. I think most important for you is to get the idea that Word2Vec uses either context words in order to predict a target word, or it uses a target word in order to predict a context word or more context words. And that each word again is represented by a vector. And typically the probability calculation is first marked by calculating the dot products of the word vectors and then transforming it into a probability distribution, because we try to learn the model word vector representations which generate high probability predictions if those words are really often occurring in the same context. That's the basic idea, and I think that's, if you understand the idea or if you get the idea, that's totally fine for the moment, okay? Those are like more like the technical aspects that you do not really need to take care of, because it's already implemented in different packages. And here, especially for the Word2Vec and the Doc2Vec model, I would highly recommend the GenSim package, because that's not only very good from a qualitative point of view, it's also very efficiently and quick, and also gives us the opportunity to work with real large data sets. And what has been really stunning once, or like the first time this model was shown and presented to the world, is that it really manages to get the similarities in a very good, in a very good sense. So we observed, or the authors observed such things as that we really can use the word vectors and do mathematical operations which resemble the meaning of the words. Okay, so meaning king to queen relates almost perfectly in the same way as man to woman, for instance. Okay, so you could really calculate with those word vectors, and it makes sense in their semantic meaning what the outcome of this mathematical operation would be. Okay, and like the quality assessment of the word vector model and stuff, and also the Globee model, or in general from word embedding models, is also something which has been taken a lot of care of. There are, for instance, many analogy tasks that typically need to be fulfilled by, or which are fulfilled by qualitatively good models, also some similarity tasks and so on. But I really would recommend you here to take a look at the original papers, because they're describing it quite well. Okay, and then last but not least, let's just quickly discuss also how this idea could be extended in not just only to generate word vectors, but also document-specific vectors. The Doc2Vec model in energy exists also in two forms, the PVM-DM and the PV-DBOW method, and it's energy as before. So we have a version where we take a look at the context of words. Okay, so this is just as before. We have a word matrix of context words that are going to be used to make a prediction for the target word, but they are, concatenated, or not concatenated, they are added to a new vector matrix, because besides to the word matrix, there will be another matrix where each row represents the vector representation of a single document. And if we are, for instance, in the first document, or the document with ID number 1, and if the target word occurs in the document number 1, then we're trying to find a vector representation such that if a certain word is often used in a specific document or in a specific types of document, that those documents are similar to each other when it comes to the vector representation. Okay, so mathematically, when we have this model, what's usually is done is that just the vectors of the context words are added, and we add another vector, which is again a parameterization of the documents that needs to be learned by the model. So it's just summing up the vectors and then make a prediction for the target word. Or we could simply try to do the other thing. We just calculate. We give a vector to every document, and then we try to make predictions if words do occur with a great likelihood in a certain document. And this is again calculated by calculating the dot products of the vectors here. But here we have not a word-specific vector. We have a vector that is the same if for all like for a single document. And in both cases, again, we are left with a multi-class classification problem trying to making high probability predictions if, for instance, certain words are used often or are typically used in a certain document, okay? And by this way, and that's like the important thing to understand your intuition, because if we solve this problem, so if we manage, for instance, here to really use a document-specific vector to predict the probability well for the usage of a certain word in a document, then if certain words are used, I don't know, in let's say document number 1, 10, and 15 do often use a specific word, then by learning this, the document vectors of those documents need to be rather similar, because only if they're similar, then the dot product calculation of each of the document vectors and the word will result in a, for instance, high number indicating a high probability for that specific word, okay? So that just means we try to learn that if certain words do often occur in specific documents, and by doing so, the result is, if we learn that the input that we use for the documents which use similar words need to be the same or need to be similar. Okay, I think like the big advantages, or maybe we will discuss this in later in other sessions and when it comes to the practical implementation. So what I really like if having a document vector is that this is something that we really can use for, I think for the financial tasks. It's more useful to have already a document vector for a whole document, because the documents typically are, for instance, a news article, it could be a Twitter tweet, it could be an earning call transcript record, it could be a report that needs to be published or that is mandatory published by a company, or maybe also by their own will. But usually we try to have like subsuming the information of the whole article and do make a prediction with it. And when we have a document vector, we already have a numerical representation of the overall article and can do something with that. And when we have word vectors, the only thing we can do here to have a single vector that is representing the document, we can only do things such as summing up all the words in the document, or using the average of the vectors in the whole document. So that again maybe stumps down a little bit of the really details in the word embeddings. So having already a document vector is something which I consider to be quite useful when we were working with financial documents, because typically we are rather interested in a numerical representation of the document at once and not in the individual words, okay? All right, there are so many more applications that it is impossible, or like many different methods that it's impossible for this course to really get them all. But I think like at least getting an idea about the idea that having textual form represented in some way by vector representation is your most important takeaway from the course. And then that to the knowledge that there are different methods, and some only care about the frequency of words, some care about the semantic meaning and everything. That's also what I think should be one of your takeaways. The specifics here, I think, are also, especially for the word vector models, I think they are really, really interesting, but needs to be studied with a little bit more care and in more detail than we just can discuss it in this form of the videos. So that's also something maybe we are going to discuss in more detail in the course itself, and also should be at least to a certain extent studied by yourself when we deal with those methods for applications in the course, okay? But like there are, I mean, the general idea, they are important to understand, and it's important that you at least get the general idea. When it comes to specific implementations, there are some practical issues that already have been solved quite well. For instance, when regarding the Doc2Vec model and the Word2Vec model by the authors themselves, they are combining their basic method with interesting statistical techniques such as hierarchical sampling or negative sampling to further improve the estimation process of the model. This is something that you may want to take a look later if you really want to focus in a detailed perspective on those methods. Something which I consider to be quite fruitful if you do so. But first and foremost for the course, I think in the first step, it's important just to get the idea of what's meant by a vector embedding here, and to get the idea that you're trying to make predictions either for the occurrence, for instance, for words in terms of the Globee model, or you're trying to predict context or target words out of the words that surround the word, okay? So that is what I wanted to share with you in this video, and everything else will be shared with you in some other forms. So take care and see you. Bye bye.